This is the second part of our Calculus 2 Power Series lesson. Our theory of convergence is the following. If we have a series from n equals 0 to infinity of c sub n times x minus a to the n, the series may converge in three possible ways. The first way is that it converges only at x equals a. That's our first possibility. The second is that it converges for x equal to all real numbers. The third is that it converges for x values within an interval, and that interval is the interval of convergence. And this interval of convergence is centered at a, and it may or may not include either endpoint of the interval of convergence. In other words, the endpoints may or may not be points at which the series converges. Okay, so we're going to look at another series, and this is not a geometric series. And for this reason, to find out where it converges, we're going to use the ratio test. So here's our series, and we've got in the numerator x plus 2 raised to the n, and then in the denominator we have n times 2 to the n. So let's take this up here. Now remember, with the ratio test, we want to find the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n, and when, for what values of x, is this less than 1? So let's move this up here. Okay, so we'll do this in black. So I'm going to take the limit as n goes to infinity of a sub n, and a sub n plus 1, so I have a negative 1 raised to the n plus 1 minus 1, so that's to the n, times x plus 2 raised to the n plus 1, this is our n plus 1, a to the n plus 1, over n plus 1 times 2 to the n plus 1. There's our a to the n plus 1. And this is going to be divided by a to the n, which is the same as the reciprocal multiplied by the reciprocal. So we have n in the numerator times 2 to the n. And then in the denominator, and I'll just extend this, we have a negative 1 to the n minus 1 and x plus 2 to the n. So I'm going to change color to red because I want to cancel out. Remember, when we have the same bases, we can do some canceling. And since we have a negative 1 base in the numerator and a negative 1 base in the denominator, we can say this is n minus 1, or n minus n plus 1. So this goes away, this negative 1 goes away, and we end up with just a negative 1 there. Now the next one is we have an x plus 2 to the n plus 1 and an x plus 2. We take the exponent in the numerator and subtract the exponent in the denominator, and we lose this term and get x plus 2 just to the 1. And now with our 2, we have 2 to the n here and 2 to the n plus 1 here, so if we subtract exponents, what do we get? This 2 to the n cancels out with this n, giving us just a 2 in the denominator, and I think we've got everything. So let me move this up, and let's keep working on this limit. Okay, so this is equal to the limit as n goes to infinity, and I did leave one thing out. This is the absolute value. We need to have an absolute value around this. There's an absolute value here and here. And so this is the absolute value of, and what do we have left? We have a negative n times x plus 2 in the numerator. And that, let's fix that. That's not a good looking n. Let's fix that n. A negative n. And then in the denominator we have 2 times n plus 1. Now when we're working this out, this limit is going to give us an infinity over infinity. We've got an n here and an n here. So we have infinity over infinity, which is indeterminate form. So we need to take the derivative of n and the derivative of n plus 1 separately with respect to n, and that gives us a 1. So this ends up being equal to the absolute value of x plus 2 over 2. And we want to know, when is this less than 1? Well, for this to be less than 1, it must be between negative 1 and positive 1. Let's get that. And there's our x plus 2 over 2. And if I multiply both sides by a 2, I have negative 2 is less than x plus 2, which is less than 2. And if I subtract 2 from all sides, I have negative 4 is less than x, which is less than 0. So now we know that the interval of convergence is between negative 4 and 0, and it's centered at negative 2. And what we need to do is check the endpoints. What happens to our series at negative 4 and at 0? So we want to know what the value of this series is at each endpoint. Let's start with at negative 4. At n is negative 4, our series goes from 1 to infinity, and it becomes a negative 1 times raised to the n minus 1 times, and the x becomes negative 4, and negative 4 plus 2 is a negative 2 to the n over n times 2 to the n. And this turns out, we can do some canceling here, because the negative 1 to the n times negative 1 to the negative 1, I can actually pull that out. Let's take this and make this, also, I'm going to continue this on, a negative 1 to the negative 1. And the reason I did that is because what we have here is this negative 1 to the n times negative 1 to the negative 1 is negative 1 to the n minus 1. And I did that so that we can see that this negative 2 to the n times negative 1 to the n, if we multiply them by each other, we get just negative 2 to the n, which means that these two cancel this one out. And what I end up with is a negative summation of n equals 1 to infinity of 1 over n, which is, that's our harmonic series. And if we remember, our harmonic series always diverges, which means that although our original series converges between negative 4 and 0, it diverges at the endpoint negative 4. Now let's find out about the endpoint of 0. So that means we're going to have a summation from n equals 1 to infinity. Now x is 0. So from negative 1, let's see, the numerator is negative 1 to the n minus 1, and the denominator, the numerator continues with 2 to the n because x is 0. And then in the denominator we have n times 2 to the n. And our 2 to the n's cancel out. Let me do that in red. And we end up with, this ends up being an alternating harmonic series, a negative 1 to the n minus 1 over n. So this one is not here the first one at n equals negative 4, we had a negative harmonic series. Now we have an alternating harmonic series, and an alternating harmonic series converges. So down here I'm going to put an equal sign, and our interval of convergence goes from negative 4 to 0, and it converges at the endpoint 0, but not the endpoint of negative 4. And if we were to write this in interval notation, we would say we converge from negative 4, but not including negative 4, to 0, and including 0. So this is our interval of convergence. It has a radius of 2, and it's centered at negative 2.